everyone, my name is Julieanna and welcome to Science Fun Week. Today we will be making a density tower. This person is a trained scientist who has all the required personal protective equipment necessary. Please be careful if attempting at home. The materials we need for this demo are honey, corn syrup, maple syrup, milk, dish soap, water, and I've just added a little bit of food coloring to it, some vegetable oil, and some rubbing alcohol. So your first step is to get a glass vase. So I have this one right here, and I'm just gonna start by pouring my honey into my vase. Be careful to not let anything touch the sides of your container. Okay, so now I'm going to be pouring in my corn syrup. Next, slowly pour in your maple syrup. And next, I'm going to be using a turkey baster to put in my milk. So try not to touch the sides of your container. So next, I'm going to add my dish soap. And as you can see, there's already some distinct layers forming. Now it's time to add some water. So we're going to very slowly use our baster to pour some water on the sides of our container. Okay, next I'm going to add my vegetable oil. Okay, and the last step is to add our rubbing alcohol. And we can see that there's pretty clear layers between all the liquids, and this is because of density. So really heavy liquids like our honey and our corn syrup will sink to the bottom of the container, but much lighter liquids like rubbing alcohol will rise to the top. And that's why we see these different layers in this container. So next, I'm going to drop some objects into our container and see where they land. So I have a nail right here that I'm just going to drop. And this nail dropped all the way to the bottom of the container. And this is because it's heavier than most of the liquids in this container. Next, I'm going to drop a couple of beads in. And the beads are falling into the oil layer because these beads are lighter than everything below the oil layer. And lastly, I'm going to add a ping pong ball. And this ball just landed right at the rubbing alcohol, which means that it's the lightest object that we put in. So it's lighter than all of these other liquids in the container. So the next part of our experiment is called floating or sinking soda cans. And this also uses the same principle of density. So I have a pop can right here. So it's a can of Sprite. and I have a can of Diet Coke. So which one do you think will float and which one do you think will sink? Well, let's see. So I'm just gonna add my Sprite can. And as you can see, it sank right away. Now let's try with our Diet Coke. It's floating. Well, why do you think that is? Well, Diet Coke uses a lot of artificial sweetener, whereas Sprite has a lot of natural sugars. And it has a lot of sugar compared to the Diet Coke. So this difference in sugar is why it floats or sinks. This can of Sprite has way more sugar than Diet Coke, so it's way more heavy and dense. That's why it's sinking to the bottom. But this Diet Coke has way less sugar, and that makes it a lot lighter, allowing it to float.
In our previous demos, you explored how different liquids have different densities, so they don't really mix very well with each other, and they separate out and sit at different levels when they're put together in a jar or a bottle. Well, water is all the same molecule, so if you mix them together, they should have no problem, right? Since it's all the same density. Well, let's see. Take a jar and fill it up to the very top with water. Put a drop of blue food coloring. In another jar, do the same, but put a different colored food coloring in there. Next, take an index card and settle it very gently on the top. Ensure that the index card touches the water and becomes a little bit wet in the middle. Also make sure that there are no air bubbles. If there are, you can go in and add a little bit more water. Once you feel like it's settled pretty nicely over top, give it a very gentle tug. You should notice some suction on the index card. Pick up your mason jar and flip it over. Notice that the index card sticks to the top and doesn't let the water fall out. This is due to certain properties of surface tension and cohesion and air pressure. If you're interested about this, check out our surface tension demo. Next, settle the jar right on top of the other one and line them up. Try not to force the top jar too down and start to gently tug out the index card. You might lose some water, that's okay. As you can see, the water slowly starts to mix and make this green color. All right, well, that's pretty obvious since water is the same density and they're both at the same temperature. But what do you think will happen when the jars are different temperatures? Let's give it a try. So this time, we've taken some ice cold water and dyed it blue, and taken some very warm water and dyed it red. Let's try it again. Notice how before, when we had blue on the bottom and yellow on the top, it mixed to make green. But what's happening here? The water is not mixing. Take a minute to pause the video and discuss why this might be happening. Essentially, what's happening here is that temperature changes the density of the water. So, hot water is less dense than cold water because the heat makes the particles move faster, so it rises. Cold water is heavier and it settles to the bottom. This time we have hot water on the bottom and we'll flip the cold water onto here. Ready? And it mixes to make a beautiful purple color. If your prediction was that they would mix, well done. The hot water at the bottom naturally rises, and the cold water, since it's more dense, sinks. And so they mix together naturally to make this beautiful purple rainbow.
Thanks for watching, and I hope you enjoy the rest of Science Fun Week. Be sure to check out our other videos.